This presentation is with regards to Math 1 to 2, Unit 6, Assignment 6, number 23. This is a question on the normal distribution. It says X approximates a normal distribution with population mean of 63 and a population variance of 8 squared. So mu is 63 and sigma squared is 8 squared, or sigma is 8. And it goes on to say that the probability that X is smaller than a certain value is 0.1401. So here now we have to find the value of X. So for starters, we can use Unit 6 to solve a question like that. So on page 21, yes, that's 21, right? It gives you information with regards to calculating the value of X. It goes on to say that situation will arise where you will be required to calculate the value of X. The scenarios will provide you with the value of mu, sigma, and the probability values. Here are some examples. Examples 5.10. So it says a geologist is researching on the lengths of rivers in Dominica. He determined that the mean length of the rivers in Dominica is 17 kilometers with a standard deviation of 5.8 kilometers. He also found out that the proportion of rivers with a length less than X kilometers is 95.25%, determine the value of X. Okay, so therefore now, it says that to begin to the question, pretend you know the value of X and you are trying to find the value of P. So you would instinctively, or first steppers would do what you are used to, which is to standardize. Then represent on the normal and standard normal curve, then go to the standard normal table for probabilities. Okay, but you have the probabilities X you're trying to find, but yet still you will standardize. So when you standardize now, Z will be an unknown, X will be an unknown, X minus mu over X minus mu, mu have mu is 17, and the standard deviation is 5.8. Okay, so, but also now it would be a good idea to translate this wordy statement. The mean, the proportion that X is less than X. Okay, X is less than a certain value. By the way, that should be lowercase x, meaning that you are shading a probability region which is greater than 0.5 towards the left. Okay, and here it is. Now, in our example now, it says X less than X equals 0.1401. This probability value is not greater than 0.5. Okay, so while this example gives you a probability value, which is a phi of, which is greater than 0.5, and you can actually find this in the table. This question now has a tail, in fact, a left tail. So for starters, you would standardize. Let's standardize. So I just said that just to bear that in mind. So first, the translation has been done already. So you just standardize. Then you move on to select an appropriate curve to represent this notation. Remember, this is less than a certain value and a probability region which is less than 0.5. So towards the left and less than 0.5. A left tail, they call that. So this is towards the left, but greater than 0.5. That's a phi of. Phi of, right? This is a left tail, less than 0.5. Okay, towards the left and less than 0.5. So this is the curve. This is the appropriate curve that you have to select. So you can use your snipping tool. Okay, and select this curve. and then you label it appropriately. And then what you do now, you go to insert and you go to drawing and you go to new and you paste it in drawing. Okay, now you have to realize now that let's use a text box to show that your Z value will be negative. Okay, whatever value you get for your Z, you're going to put a negative sign by it. Okay, because that's a value that will be that will be on the left side of 0. Okay, on the standard normal curve. 0 will be there. Okay, by the way, your mean will be here. Your mean is 63. The mean is 63. And X now will be a value that is smaller than 63. That will be your normal curve. Okay? And your standard normal curve now, mu will turn to 0, and your Z now will be a negative number. Okay? So you just snip it. And if you are using Google Docs, you paste it in drawings. Okay? And then you can edit it as it. But importantly, please note that your Z will be negative. Now, to get the Z now, as you can see now, this table is calibrated for phi of Z. Phi of Z meaning probability values which are greater than 0.5. Now, you are provided with a value, a probability value, which is less than 0.5. Okay? 0.1401. That's that region here. Okay, but X less than X being 0.1401, the probability of is the same as the probability of X greater than that value. Okay, being 1 minus 0.1401. So in other words, you've got to subtract this value from 1 in order to go into the table to find the probability value. Okay, please bear that in mind. These only values are at least 0.5%. So you go to subtract this probability value from 1 and go into the table and get the Z. And don't forget your Z, you have to put a negative sign to it and then reinsert it back into the Z formula, whatever value you get. Don't forget to put your negative sign and then you solve for X. By the way, this also be lowercase x, italics. So you simply continue with this. So unlike example 5.1, where your probability value is already greater than 0.5, it's a phi of. So, and furthermore, you don't have to attach a negative sign because the Z is already positive. So you just plug it in 1.67 that was obtained, and you actually solve for X. Example 5.11 is another scenario. Okay. Here, the probability value is less than 0.5. Okay, it's a right tail. So as you can see, this value had to be subtracted from 1. Here's the algebra, 0.8389, and the Z was obtained, and it remained positive, and you just substitute and you solve for X. But in this case, you've got a left tail. So after you subtract from 1, you've got to attach a negative sign.